kind of wild when you think about it, right?
Yeah.
We always picture Mars as this super dry, desolate place.
Yeah.
But there's actually a ton of evidence it used to have, like way more water.
Oh, absolutely.
Like we're talking maybe even more than Earth's Arctic Ocean.
It's true. We see signs of it everywhere, like ancient rivers, lake beds. There's even a chance there was a massive ocean covering a huge chunk of the planet.
Hold on, a whole ocean. Okay, now I'm picturing myself on a Martian beach trying to figure out the sunscreen situation.
Right.
But seriously, where did all that water go? I mean, that's got to be a big piece of the puzzle if we're talking about life on Mars.
It's a huge question, and it's one of the main things NASA's Curiosity rover is investigating.
Okay, so Curiosity's not just, like, finding cool-looking rocks, right?
No, not at all. It's been exploring this place called Gale crater. Scientists are pretty sure it used to be a lake billions of years ago.
Wow.
And the data it's sending back, it's seriously shaking up what we thought we knew about Martian climate change.
Okay, so what's making these findings so different? What's Curiosity found?
So it's been analyzing these minerals, carbonates.
Carbonates.
Yeah, and they're like little time capsules.
Okay.
They preserve incredible details about the environment they formed in. Like, we're talking temperature, the acidity of the water, what the atmosphere was like. It was all locked in there.
So each rock is basically a snapshot of ancient Mars.
Exactly.
That's amazing.
And get this, the carbon isotopes in these Martian carbonates, they're heavier than anything we've ever seen. On Earth, on Mars, anywhere.
Okay, you're going to have to bear with me because isotopes have always been a bit of a mystery to me.
Sure.
What makes these heavy isotopes so important?
Okay, so picture a pot of water simmering on the stove, right?
Got it.
As the water evaporates, the lighter water molecules, those with fewer neutrons, they kind of float away more easily.
So the heavier ones are left behind.
Exactly. And over time, that remaining water, it becomes more and more concentrated with those heavier isotopes. And what we're seeing with these carbonates on Mars, those super heavy carbon and oxygen isotopes, they're telling us that evaporation on a massive scale was happening.
So Mars was basically like a giant pot of water slowly evaporating.
In a way, yes.
But on a planetary scale, that's incredible.
Yeah.
But does that mean Mars was always going to end up like it is now? This dry, totally inhospitable desert?
Not necessarily, no. It really depends on how that drawing happened. You see, this study, they proposed two main scenarios, and they both kind of have huge implications for, the possibility of life on Mars.
So what are the two possibilities? Lay it on me.
All right, so the first scenario, it involves these cycles, like wet and dry periods.
Okay.
So picture this. You've got periods of rainfall, right? Water's flowing, but then, bam, intense evaporation, everything dries up.
Wow, that's got it pretty rough for anything trying to, survive, right? Let alone get a foothold.
It would have been a wild ride, for sure.
But are you saying life could have, adapted to that? To that kind of back and forth? What would that even look like?
It's definitely not impossible. I mean, look at Earth. We see examples of that kind of adaptation in some seriously extreme environments. Think like Death Valley or the Atacama Desert.
Yeah, okay.
Those places get hit with these long, dry periods, but then boom, short bursts of rain, super intense. And life there, it doesn't just survive, it thrives.
That's incredible. Okay, so even with Mars going through these, huge climate swings, it might not have been a total bust for life. What about the second scenario? How does that one work?
Okay, so the second possibility is that the water in Gale crater, it was already super salty, even saltier than Earth's oceans.
Oh, really?
Yeah, and eventually it just froze over. That creates a completely different environment, obviously, and probably way harsher for life to, pop up.
Okay, so picture this. Giant frozen lake, except it's insanely salty. Not exactly the relaxing Martian beach vacation I was picturing earlier. But wouldn't all that salt make it almost impossible for anything to survive? Even, microscopic life.
It's true. That much salt is a huge challenge. But then again, even here on Earth, we keep finding these organisms. They're called extremophiles.
Yeah.
And they can handle stuff we thought was impossible. Like literally in the Dead Sea, almost 10 times saltier than the ocean, there's microorganisms just hanging out.
No way. So even in this, super salty frozen wasteland, life might still find a way. Life is so weird. I love it. Okay, I'm hooked on both these scenarios. But how do we figure out which one's more likely?
That is the million-dollar question, isn't it? And I think it's important to remember we're not just pulling these ideas out of thin air.
Right.
There is other evidence from Mars that supports both of them.
Okay.
The thing about this new isotope data, it's like this. It's not that we have to throw out everything we thought we knew. It's more like adding a brand new crucial chapter to the story of Mars.
So we're not rewriting the story, just getting a clearer picture.
Exactly. And you know what's even more interesting? This story, it's not just about Mars. It's way bigger than that.
Wait, what do you mean? We've been talking about Mars this whole time. How does this connect to anything beyond that?
Well, it's like this. If we really want to find life on other planets, right, we got to understand the whole picture.
Okay.
How planets become habitable in the first place and how they might, lose that ability. And Mars, it's like this perfect lab right here in our cosmic backyard.
So by studying what happened on Mars, are you saying we can make better guesses about other planets? Like whether they went down a similar path or if they maybe held onto their water and are totally teeming with life?
Exactly.
Yeah.
And every little bit of data we get from Mars, especially about its climate way back when, it brings us closer to understanding what makes a planet right for life, at least life as we know it.
That's amazing. So we're taking what we're learning from Mars and kind of using it to guide our search for life everywhere. This isn't about little green aliens anymore. It's like the whole big picture of life in the universe.
Exactly. And there's this other layer to this whole thing, right? We've been talking about finding signs of past life on Mars.
Right.
But what if the biggest discovery isn't about finding aliens at all?
Okay.
What if it's figuring out how a planet that maybe could have had life loses that ability, I mean, that knowledge that could be even more important in the long run, especially now with everything going on with our own climate here.
Wow, yeah. It really makes you think, doesn't it? We tend to think of planets as these, fixed things, but Mars is a pretty stark reminder that change is constant, even on a planetary scale, you know what I mean? And understanding those changes, those big shifts, feels more important than ever.
It really does. It highlights how important it is that we study how planets evolve, like what makes them habitable, what causes them to decline. And it reminds us that even Earth, for all the amazing things about it, it's not immune to change either.
Yep.
It's so true. Okay, well, my mind is officially blown. If you had to pick one thing for our listeners to walk away with from this whole deep dive, what would it be?
That's a tough one. I'd say this. Next time you see a picture of Mars, all red and dusty, try to picture it differently. Imagine the rivers, the lakes, maybe even that huge ocean, all that used to be there. And think, figuring out how all that water vanished, it might be the key to finding life somewhere else out there. And, maybe even to protecting our own planet while we're at it.
That's a powerful thought to end on. It reminds us that exploration isn't just about what we find out there in space. It's about what it teaches us about ourselves and our place in all of this. Thanks for joining us for this incredible deep dive into the mysteries of Mars. Until next time, keep exploring.